Now we are going to examine nomenclature of some simple organic compounds that contain heteroatoms. Heteroatoms are atoms other than carbon and hydrogen. We will start with nomenclature of alkyl halides. First, we should look at parent chain of compounds that contain heteroatoms. With exception of alkanes, all other classes of compounds contain a functional group. In an alkane, as in this example, the longest chain is always the parent chain. When naming other classes of compounds, parent chain is the longest chain that contains the functional group, even if there is another longer carbon chain. So, when a class of compounds is named after its functional group, the parent chain is the longest chain that contains that functional group. You can see in this example, this is an alcohol. There is actually a longer chain, but parent chain is the longest chain that contains OH group.
Alkyl halides, in addition to carbon and hydrogen, contain one or more halogen atoms, and those would be fluorine, chlorine, bromine, or iodine. General symbol in organic and inorganic chemistry for halogen is X. So if we write the general formula like this, Rx, R stands for an alkyl group, and X stands for fluorine, chlorine, bromine, or iodine. So Rx is general formula for an alkyl halide. And here are some specific alkyl halides, and you will learn in a minute how to classify and name them.
Classification of alkyl halides is according to degree of substitution of carbon atom that is bonded to halogen. So they are classified as primary, secondary, or tertiary alkyl halides. Primary alkyl halide has carbon atom that is attached to halogen bonded to only one other carbon atom. So here are two examples of primary alkyl halides. Note that methyl group in which carbon is not bonded to any other carbon atom is also classified as primary. And sometimes we also separate methyl group as separate class of compounds. We have already learned about classification of primary, secondary, tertiary, and quaternary carbon atoms earlier, so this is simply application of that classification. Note that quaternary carbon atom is bonded to 4 other carbon atoms, so there can't be quaternary alkyl halides. Only primary, secondary, or tertiary alkyl halides are possible. So here is general formula of a primary alkyl halide and two examples. Secondary alkyl halides have 2 carbons attached to the carbon atom that is attached to halogen atom. Note how we use general formula for halogen as X. And here are 2 examples of secondary alkyl halides. Finally, tertiary alkyl halide has 3 carbon atoms attached to carbon attached to halogen. And again, 2 examples. Here are some additional examples of primary, secondary, and tertiary alkyl halides. So 2 examples of primary alkyl halides. Top one is represented as condensed structural formula, bottom one different compound as a line formula. And then again 2 examples of secondary alkyl halide. Top molecule is represented as condensed structural formula, bottom one as line formula. And tertiary alkyl halide, again top one represented as condensed and bottom one as line formula. Note that some of these compounds are cyclic. Also note how we indicate degree of substitution in parentheses. So 1 degree of substitution, 2 degrees of substitution, and 3 degrees of substitution. So 1 degree of substitution means primary compound, 2 degrees secondary, 3 degrees tertiary. So instead of writing primary, secondary, tertiary, we can indicate degree of substitution in parentheses. But they are never read as 1 degree, 2 degrees, 3 degrees, or 1st degree, 2nd degree, 3rd degree. They are always called primary, secondary, tertiary. So always use terms primary, secondary, tertiary. And now we should look at names of alkyl halides. First, common or trivial names of alkyl halides mean that they are named as basically salts. This is derived from inorganic nomenclature. So they are named as if they were ionic compounds. We know that they are not ionic compounds. We know that alkyl halides are covalent compounds. They contain covalent carbon-halogen bond. But still, they are named as if they were ionic. Recall from general chemistry how ionic halides are named. They are named as, let's say, lithium fluoride, sodium chloride, potassium bromide, cesium fluoride. So cation, space, anion. And anion has this IDE suffix. So in this case, we name alkyl group, or in general hydrocarbon, space, and then halide, fluoride, chloride, bromide, or iodide. So here are a few examples. First one, ethyl group, so ethyl, space, fluoride. Second one, isopropyl group, so isopropyl bromide. And third one, tertiary butyl group, so T-butyl or tertiary butyl chloride. This nomenclature is relatively easy. It's quite commonly used, but problem with this nomenclature is that only simple alkyl halides can be named this way. Obviously, if alkyl group is rather large, then it's very difficult to name it as a substituent because it must have parent chain and substituents on parent chain, and so this kind of nomenclature becomes impractical. So for that reason, we use UPAC or systematic nomenclature. So common names or trivial names are used only for very simple compounds. If compound has any higher degree of complexity, it's a bit larger, then we have to use UPAC or systematic names. And here are some examples of UPAC or systematic names. According to UPAC or systematic nomenclature, these compounds are named as haloalkanes. So note that even in the title, the class of compounds is named differently, haloalkanes instead of alkyl halides. That's because, according to common names, they are named as alkyl halides. Alkyl halide. Now they are named as haloalkanes. So the parent chain is the longest chain of carbon atoms that contains halogen atom. And halogen atom is named as substituent. When halogen atom is named as substituent, it has suffix O. So it's named as fluoro, chloro, bromo, or iodo. And simply, compound is named as if it were an alkane, and halogen is treated as another substituent, the way we would treat methyl, ethyl, isopropyl, tertiary butyl group, any other substituent. And so it's given name, it's assigned number, and it's listed in alphabetic order together with other substituents. So this nomenclature is much more convenient, but it is a bit less common. So first example, the longest chain has 6 carbon atoms, so this is hexane. On carbon 2, substituent is bromine, so it's going to be bromo, and on carbon 4, substituent is methyl group, so it's going to be 4-methyl. So name is 2-bromo-4-methyl. Of course, bromo alphabetically comes before methyl. In the next example, longest chain has 8 carbon atoms, so this is octane. And then we have substituents 4 and 5. Now, this is a tie. Numbering them from left to right or right to left, two substituents have same set of numbers, 4 and 5. And substituents are chloro and isopropyl. Because chloro comes alphabetically before isopropyl, then chloro is assigned smaller number. So correct name is 4-chloro 5-isopropyl octane. Next example, we have dihalide, 2 halogens. Longest chain 6 carbon atoms, hexane, and again we have a tie. We have same set of numbers, 3-4, numbering hexane chain from left to right or right to left. So it's 3-bromo-4-chloro hexane because bromo is listed before chloro alphabetically. Yet another example of a tie. Again hexane, now it's 2 and 5, numbering them from left to right, right to left, same set of numbers 2 and 5, and since chloro comes before methyl, chloro gets smaller number, number 2. So it's 2-chloro 5-methyl hexane. You may want to pause video here and try to name these on your own and then match your names with names that are provided here. And finally, one trihalide. So Make sure that you get longest chain correctly here. It has 5 carbons, so it's pentane. And so it's 2,2-dibromo 4-chloropentane. Again, smallest set of numbers is 224. This completes video on nomenclature of alkyl halides, and next we'll be looking at nomenclature of alcohols and ethers.